Hey guys, today we're going to learn about variables. Now, variables are going to start to give our programs memory, which is going to unlock a lot of new use cases for us. So to start wrapping your head around what variables are, let's take a look at the context list in our smartphones. Now, each of these names refers to a phone number, but by saving them as names, I don't need to remember each of the numbers individually. And this is great because it's a lot easier for me to remember my friend's name like John Smith than it is for me to remember a random sequence of numbers. Another great thing about this is if John's phone number changes, I don't need to remember the new number either. All I need to do is update the contact entry in my phone, and then I'm done. As long as I can remember my friend's name, John, which hopefully I can, then everything else is taken care of. So here my friend's name, John Smith, is the variable, and the value it refers to is his phone number, which is just a sequence of digits and characters, which is really hard for people to remember. And because we're saving it in a variable, we don't have to remember it. So this makes our lives a lot easier. And now we're going to take a look at how we can do this exact same idea in Python. So let's start exploring variables by taking a look at this phone number that we're storing as a string. Now, if you're wondering why we're storing the phone number as a string rather than an int, because it does contain a bunch of numbers in it, think about what a phone number really represents. So it's not a regular number that you could just do math operations on. Instead, it's kind of a sequence of digits that has specific parts inside of it. So these three digits here are the area code, and this one is the country code. So the way that this number is arranged has a very specific meaning that's different than integers. Also, phone numbers usually have special characters in them, so like parentheses right here, they have spaces, and they also have dashes. All of these things we can't store in ints. So that's why we're going to be storing the phone number in a string. But if you look at what we just did, there is actually a problem here. Once I created this string, it's gone. I don't have any possible way to reuse it. If I did want to actually use this phone number again, I'd have to create it again from scratch. And to do that, I would have to actually create a new string, kind of like this. And then my program just forgot about it again. So I still don't have a way to use this new string without creating another new one. And this is where variables come into play. So we can actually tell our program to remember what we're creating so that we don't have to create it again in the future. And the syntax for using variables is like this. So we put the name of the variable, the equal sign, and then the value of the variable. Now the name of the variable is what we want to call our variables. We can give our variables our own custom names, and we're going to look at that in a second. The value of the variable is the thing that we want to actually store. So in this example, it's going to be this phone number up here. And then the equal sign is something called the assignment operator. The assignment operator takes the value on the right and assigns it to the variable name on the left. So filling all of this in, we know that the value we want to store is this string, which represents a phone number. And then we can call it whatever we want. So right now, let's just call it x. X is going to be our variable name. Okay, we did it. We made a variable. Now, if we want to actually see that variable, all we do is type the variable name into the shell and press enter. And Python gives us back the value of the variable. So we can see the phone number that we just stored right here, and we didn't have to type it again. All we had to do was type out x. Now that we've created this variable, we can use the type function to check what data type it is. So we can use type x, and we get back string. And that makes sense, right? Because x is this variable with the value of this phone number, which is a string. So when we say, hey Python, what's the type of x? It's giving us back string. Now that we've created this variable, Python's going to continue to remember it no matter what we do next. So say I had to do some math operations, just as an example. We had to do 6 divided by 2, then we had to multiply 2 by 10. At this point, even though we've done a few other operations, we can still access our variable x, just like we did before. So Python didn't forget anything just because we changed gears and started doing something else. Now imagine that in this example I had done a lot of math, much more than just these two operations here. And I was really focused on what I was doing, and I filled up this entire screen with just math operations. But at that point, I needed to use this phone number again. Well, if I had forgotten that we called to x, I'd have to scroll all the way up, find where we actually created the variable, and then extract the value x so that I could check this phone number again. And depending on how much work we had done here, that could be pretty cumbersome. And one of the reasons this is so difficult is the variable name we chose isn't really intuitive. It's not very obvious to me that X refers to my friend John's phone number. Remember, we can pick our variable names, so we can fix this pretty easily. Let's make a new variable that is a little bit more intuitive. And instead of calling it X, let's call it John's number. Whoops, and we run into a problem when we try to do this. So the issue here that is in Python, variables can't have spaces in them. So that's why we're getting the syntax error here. Which brings up the question, what do we want to do if our variable names need to be more than one word so that they're descriptive of what they actually represent? And there's two common ways to deal with this. The first is to use an underscore where the spaces would be. So John's space number would change into John's underscore number. Another way to do this is to start the first word with a lowercase letter and then capitalize the first letter of all the other words. So what that would look like is we'd write the first word John in all lowercase, and then we would capitalize the N in number. So the first way we looked at with the underscore is something called snake case. And this other way is called camel case. Both of these are used a lot in various programming languages, but in Python it's generally recommended to use snake case. So that's what we're going to be using moving forward from here. So at this point we have our variable John's number using snake case. It refers to our friend's phone number. It's an intuitive naming choice, so it's easy for us to remember. So everything's good at this point. But what happens if John changes his phone number? Well, we can actually update it like this. And now if we check the value of our variable John's number, we see the new value. So essentially this line says, hey, I don't want John's number to be the old value anymore. I now want it to refer to this new value ending in 01. And this is just like when we change a phone number in our contacts list in our smartphone, like we looked at in the intro. If we go in and actually edit a phone number, our phone's not going to remember the old number anymore. It's just that contact will have the new number. And that's the same way that variables work. So this idea is called variable reassignment. And when you do variable reassignment, you need to be careful that you actually don't need the old value anymore. So this value right here is pretty much gone at this point. We could create it again by making a new string, but if we needed to refer to it using a variable, we can't without making a new one. So once you do variable reassignment, the old value is gone, and you only have access to the new one. But let's think about that for a second. So if you did need to keep the old value for some reason, how do you think we could do that? Try to think about this. Pause the video and give it a shot. So one way we can achieve this is to save the old phone number in a second variable. So let's first reset to how we started. So we're going to have John's number referring to the old phone number. What we could do is make a new variable called John's old number and set it equal to the original number, and then update John's number like we did here. And now if we check the two values, you can see we have the old number in this variable, John's old number, and we have the new number in John's number. Now this definitely works, but one issue with the way that we did it is we had to create the original string 2 times. We had to first store it in John's number, and then we had to create it again when we stored it in John's old number. And there is a way we can actually avoid this. So let's again reset to our initial state. We have John's number equaling the original phone number. And our goal is to store this in John's old number and then store this new phone number in John's number. And we want to do it without recreating the string again. Well, we can actually do something like this. We can say John's old number equals John's number, and then say John's number equals the updated value. Now this probably looks pretty confusing if it's the first time you're seeing something like this. So let's take a look at what's going on behind the scenes. Okay, let's take a look at what's really going on here. Now, as we navigate through this, I'm going to be using this purple color up in the top left to point out where we are on the board. Now, this whole board is separated by this blue vertical line right here. To the left of this line is our code. And to the right, we're kind of sketching out what's happening behind the scenes in our computer. So let's start with the first line of code. In the first line, we're creating a variable called John's number, and we're setting it equal to a string with the first phone number in it. So moving over to the right side of the diagram, we're creating this variable John's number right here. And the string that we're assigning it to is actually this guy right here. And this is a simple memory model. It's just a visual way of kind of representing what's in your computer's memory. And we're just using a rectangle here that's divided into two parts. The top is the data type and the bottom is the value. So we have our variable and we have our data structure, and we want to assign the variable to the data structure. So to do that, we're going to represent this with this arrow. And this is just saying John's number refers to this place in memory that holds this string data structure. So this is what our memory model looks like after the first line executes. Now the second line, we're saying John's old number equals John's number. So we're introducing a new variable, John's old number, and we're making it refer to John's number. Now at first, it seems like we're probably doing something like this. However, when you set a variable equal to another variable, you're actually assigning it to the value of that other variable. So rather than our arrow being like this, it actually looks like this. So after line 2 executes, we have John's number and John's old number both referring to the same piece of memory in our computer. And remember, that piece of memory is just a string with this value right here. Now finally, when we move to line 3, we're saying John's number equals a new string, and that's this guy right here. And when this line executes, two things happen. First, we have a new arrow coming from John's number that refers to this new piece of memory, and we actually kill the old arrow. So John's number has nothing to do with the first string anymore. And this is because variables can only refer to a single piece of memory at one time. So when you set it to a new piece of memory, like we do right here, the old connection doesn't exist anymore. So if we clean up this diagram a bit, now we can kind of see what's happening. We have John's number pointing to this string right here, and we have John's old number pointing to the first string. Now we have John's old number referring to the old number, and we have John's number referring to the new number. Another cool thing we can do with our variables is use all the operators that we've already learned so far. So if a variable refers to a string, like this one, we can use all the string operators on it. If a variable refers to an int, we can use all the math operators on it, and so on. So let's look at a few examples here. Right now, if I want to display John's number, we know that we can do that by just using the variable name. But if I wanted to display something a little more meaningful, like maybe just say John's number is, and then show this number, we can use string concatenation to do that. And a way to think about why this actually works is when you use a variable, it basically just gets replaced by the value it refers to. So this entire line essentially becomes this. And we've already seen how you can concatenate two strings together. Now, just like we could do string concatenation, we could also do string repetition with John's number. So basically, anything you could do with strings, we can also do with this variable because this variable refers to a string now. Let's create another variable called age that stores an integer. Let's say age equals 25. Cool, now if we want to see that value, just like before, we use the variable name. And now since our variable refers to an int, we can use all the math and comparison operators that we've seen so far. So let's say we wanted to write a statement that checks if a person is over the age of 40. Well, we already have their age stored in our age variable, so we could just say age greater than 40. And we're going to get back the Boolean value, true or false. And in this case, obviously it's false because we set age to 25. We could also write a statement that checks if the person will be over 40 in 20 years. And to do something like that, we could take our current age and add 20 to it and check if that value is greater than 40. And again, working through this from left to right, we take our age, which is 25, we add 20 to it, giving us 45. So we're basically simulating 20 years in the future. and then checking if that value is greater than 40. So this becomes 45 is greater than 40, and obviously that's true. So that's going to wrap up our intro to variables in Python. Hopefully this was helpful and you feel like you have a grasp on how to start working with variables and a little bit about what goes on behind the scenes in memory when you do things like create variables and variable reassignment. Remember, the best way to learn this stuff is to actually do it, so like code it out on your own. So go through the examples we did on your own computer and then try to come up with a few of your own as well. If you need any help thinking of ideas to try out, let me know in the comments and I can try to help out. If you did enjoy this, make sure to press the like button and subscribe. And as always, thanks for watching and I'll see you in the next one.